Hello, I am Serena, and yes, I am a product designer, which means that I spend most of my time thinking about things like colors and layouts and user interactions and flows and how all these nice things affect user behavior. I also happen to be a bit of a security nerd. When I was growing up as a teenager, I spent most of my time just on those reverse engineering hacking puzzle sites, which was a great time. But I'm here today, all the way from New Zealand, because I care about both of these things. I care about both design and security. And I'm here today because there is a pervasive myth that still exists. It's the myth that usability and security are mutually exclusive. The thought that to make something secure inherently makes it hard and difficult to use, and conversely, making something nice and easy to use inherently makes it less secure. By the end of this talk, I hope to convince you all that this is not true, and in fact the opposite is true. Good user experience design and good security cannot exist without the other. And when you think about it, it makes sense. A secure system is controllable, it's reliable, and hence usable. A usable system reduces confusion, reduces frustration, and leads to better security outcomes. And while I'm sure that most of us in this room would agree that everyone deserves to be secure without being experts, I'm not sure if our current way of working actually enables that. Because if everyone deserves to be secure without being experts, we need to stop expecting everyone to become security experts. I know this is possibly hard in a room full of security enthusiasts, I assume, to hear, but the truth is no one really cares about security. Well, they care about security in theory, but no one cares about it at any given moment in time. They're caring about their task at hand. Given a choice between dancing pigs and security, the user will pick dancing pigs every time. Now, this quote is from '99, so the memes are a bit outdated, but the idea persists. We need to stop expecting everyone to invest all of their time to care about security. But that's what we expect right now. And when people don't invest this time, we shame them. In security, there is a culture of shame. Now, I'll be the first to admit that I've wholeheartedly engaged in all of this stuff, whether it be laughing at people posting pictures of their credit cards online, or laughing at people getting scammed for their passwords on IRC, trying to convince people to use something that's completely unusable, and then belittling them when they inevitably can't figure out how to do it. Security is hard, and while it's understandable for us to all lament that we live in a world full of idiots, it's unhelpful. And as people working in tech, for us, that's downright lazy. It's laziness on our part, pure and simple. They wanted to complete a task, and we have failed to allow them to do that in a secure and easy way. And that's on us as people making the software, not on them. And by the way, who here has typed in a command in terminal and it failed, and then you just sudoed the same command without even thinking twice? We all just want to get things done. And it's okay that no one cares about security because they shouldn't have to. We should. It's our job to build accessible, performant, secure code for everyone. Whether we're security experts, developers, managers, designers, that's our job. In design, the focus is on the end user experience. So instead of overwhelming them with complex technical instruction, we can build security that's intuitive, that's friendly, and stuff that people will actually use. Design thinking is just another tool in your problem-solving tool belt. So after today, when you get caught in a tug of war between security or usability, I want you to consider 4 things. These are 4 things that designers think about every day, or should, but they tend to get lost in the complex technicalities of security work. The first is paths of least resistance. So in security, we're used to putting up a lot of walls. Oh, sorry, did you want to do a thing? Have you considered not doing the thing? You're trying to access Lotus Notes? Sorry, try tomorrow. Did you want to connect to a server to do your job? Have you tried becoming a detective and trying to get to the bottom of whether you can trust the server or not before you do your job? Computers were a mistake and we should just turn off the internet. To be fair, all of these warnings and annoying pop-ups, they're a symptom of security being tacked on to the end of the development cycle. So if design and security start working together, we can stop thinking about putting up walls all the time and start thinking about carving rivers. We can direct people in such a way so that the path of least resistance matches the path of most security. And in many ways, we're already doing this. Consider the secure by default principle. Secure by default is just the trivial path of least resistance. So what happens if you do nothing? It can be as simple as defaulting to the least privilege option in a dialogue, or if you want a physical analogy, consider a blender that has a motor that doesn't turn on unless you put the lid on securely. You have to do extra work to screw that up. When it comes to crafting paths, make security actions a natural part of the process instead of extra homework that the user has to do. So, for example, if you need their phone number to set up 2FA, don't count on them on going to your settings menu and finding their way through. Make it a natural part of the sign-up process. If I'm already prepared to sit down and fill out a long-ass form, making sure that you've got my details is not going to be a huge ask. Group similar tasks. So if I'm here to check on a status, to get something done, I'm not going to go through a setup process, no matter how much you try and convince me. It's not what I'm currently thinking about. It's natural for all of us, as humans, to be economical with our physical and mental resources. So security isn't what people are thinking about all the time. They're thinking about their task, right? So therefore, our primary consideration should be to keep the user's motivation and our security goals in line with each other. When these goals become misaligned, that's when people will start subverting your security processes, whether unintentionally or even intentionally. Take security warnings, for example. Now, to be fair, these have gotten a lot better in the last 6 or 7 years, but I'm sure we've all come across people who find this page and just breeze through it without a worry in the world. Why is that? Well, figuring out whether to trust the connection or not is not their current goal. What happens when an everyday person sees this warning? Oh, no, my connection isn't private. Okay, but I really want to know what pileofcats.exe is. So it's okay, because I am an adult and I know how to internet, and I know all I have to do is click on this tiny little link to proceed. People tend to rush through security warnings because it's misaligned with their current goal. So why doesn't friction work here? Well, I should clarify that when I talk about paths of least resistance, it's really about paths of perceived least resistance. If dismissing 10 security warnings in a row is how I learn to get my task done, I'm going to do that every single time. And the more I see those warnings, the less I'll see them at all. Each false alarm reduces the credibility of a warning system. Now, many studies have been done about this. Here's one from Anderson et al. They watched participants view repeated security warnings through an fMRI machine. And they saw that people did less visual processing of the dialogues as soon as after 2 exposures. So it's not like they read them and ignored them. They visually processed them less. This is pretty bad. And if you think end users ignoring your security warnings is bad, Think of your colleagues doing it, your employees doing it. Shadow IT is a process that employees actually take instead of the one sanctioned by your security team, because usually the sanction process is way too hard. When security processes are presented as something that obstructs rather than something that enables, people will find another way to get around it because they need to do their jobs. Here's a classic example. How many of you have worked for a company with a password rotation policy? I have. Everyone has. And we all know what happens, right? Because compulsory password rotation leads to short passwords. It leads to people reusing your passwords. It leads to stick it on the computer passwords. Password rotations don't work. The thing is, if we keep putting obstacle courses inside of our products, our applications, and even our organizations, it turns out people just get really good at doing obstacle courses. So how do we get rid of these? Well, first of all, we can use security tools for security concerns. This sounds like common sense, but if I had a penny for every time an employee turned off the company firewall just so they could listen to Spotify, I'd have many pennies. So if your employees are spending too much time on YouTube, that's not a security concern, that's a management concern. And if we start blocking enough non-security threats, people will smart up to it. They'll recognize that, and they'll get really, really good at subverting your security processes. When we want to make good paths, don't make people think. Again, build rivers, not walls. Make the secure path the easiest path. A really good example of this is Beyond Corp at Google. I don't know if Neil is still here from Google, but he'll know about this. So it was developed in response to a threat, and instead of traditional boundaries of being on a safe network or off the safe network, they removed the security perimeter entirely and pretty much just put everything on the internet. Now this is great because once you put everything on the internet, suddenly you actually have to do the work of securing all of your applications, reliably authenticating your users, and reasonably mapping out their application use. But what made it so successful wasn't just the ingenuity of the model. They had an extremely strong focus on the user experience when it came to implementation time. They designed their tools so that the user-facing components were clear and easy to use, and for the vast majority of them, completely invisible. And that's how security should be: easy, reliable, normal, and invisible. Build rivers, not walls. Align your goals with the end user's goals. Okay, so what are the end user's goals? To know that, we have to know their intent. What is everyone's intent? Having a clear view of everyone's goals sets the foundations of how you approach problems later on. This sounds like common sense, again, but we forget about intent all the time. It's where the tension between usability and security occurs in the first place. And it's easy to forget about, because trying to infer intent is really difficult. And what ends up happening is, instead of thinking about intent and desired outcomes, we fall back into everyday patterns like, oh, I'm a designer and I care about usability, so I need everything to be easy. Or, I'm on the security team. I love that image. I'm on the security team and my responsibility is security, so I need to lock everything down. The next time you catch yourself falling into these patterns, remember, it's not my job as a designer to make everything easy. And it's not the securities team job to lock everything down. Okay, so what is our job? All of our jobs, everyone in this room, is to make a specific action that a specific user wants to take at that specific time, in that specific place, easy. Everything else we can lock down. Therefore, if we want to tighten security without sacrificing usability, we need to know the end user's intent. Now, this is easier said than done, of course, but next time you come across this tug of war between usability and security, maybe step back and ask, who are they? Do we not know? Does our authentication system need to be more robust, more reliable, more trustworthy? When is it? Where are they? Do we need better behavior modeling around time and location? Are these things too easily spoofed? What are the usual actions that they do? What is unusual? Have we got past data of past behavior? Do we know what's expected? Do we know what's unexpected? Like when I flew over here for this conference, for example, I had to call up my bank and tell them, hey, I'm going to be traveling. Because they have a behavior model that says it's unlikely for legitimate transactions to occur outside a customer's home country. So if I didn't let them know, they'd block my transactions or sometimes even my card and my account. Now this is a pretty rudimentary way of inferring intended behavior versus unintended behavior, and we probably have more data to work with in our companies, but the idea is the same. When we know an end user's intent, it means we can start considering communication, how to communicate to that intent. It's time we think about communication a bit differently. It's not just a mushy human flesh-based I/O that's sometimes a drag to deal with. I want everyone in this room to start thinking about communication, and more specifically miscommunication, as a security vulnerability. This is the thing that social engineers exploit, areas of ambiguity, of confusion. So here's a question. What are you unintentionally miscommunicating? This is probably a rhetorical question, but who here knows what the secure lock on Chrome and Firefox means? You can yell it out.
It's got SSL or TLS on.
Yeah, exactly. So the secure lock means that your connection is encrypted and that the domain name is actually who you're talking to, based on some magical security authority, probably in wizard robes. So yeah, that's cool. Everyone here knows that because we all work in tech. But what do you reckon the everyday person thinks this means? They think it means secure because it says secure. But we know that's not necessarily true. So that's a miscommunication, a small one, but a miscommunication. And whenever there exists a miscommunication, there exists a human security vulnerability. So let's say I got bored one night and I felt like doing some crime. This is a common example that could apply to everyone, so let's just go big here. Okay, so I could go and I could register a pretty legit sounding domain name. I'm sure you know where this is going. I can go get myself a nice free SSL certificate, and with my extremely technical elite hacksaw skills in HTML and CSS, I could set up a pretty legitimate phishing website that people think is secure. I should probably say that I didn't actually do this. This was with screenshots and Keynote. But phishers do this all the time. And thankfully, Google has noticed this. And they're now rolling out some updates, which means that they'll be removing the secure logo and the secure icon. Because this is where we want to be. We want security to be the default. We want security to be normal. We don't want to call it out. We want to raise alarm when something is wrong, but if everything's going great, we don't need a gold star for it. So this is being mitigated, but this is a pretty good example of how even a slight miscommunication can lead to some really bad security outcomes. So, do your end users know what you're trying to communicate? What is their mental model of what's going on compared to yours? Which brings us to our final consideration, mental models. Now this is the most important consideration because it's the user's mental models, it's their expectations of what's going on that defines whether your system is secure or not. Think about it. A man-in-the-middle attack isn't inherently insecure. Telephone is just a string of man-in-the-middle attacks, but it's not a security incident. It's a pointless children's game that tells you which one of your friends is a lying poop. Brian. No, man-in-the-middle attacks are bad in our cases because our users expect their data to go to an expected party, and that man in the middle is unexpected. A system is secure from a given user's perspective if the set of actions that each actor can do are bounded by what the user believes it can do. Therefore, designing secure systems means that we must understand the user's mental model, how they expect things to work, not just how things actually work. We can do this in two ways, and I think we should use a combination of both. First, we can try and find their mental model and match to that. And the best way to do this by far is to go to customer sessions or user interviews. Ask your designers and UX researchers if you can come and sit in the background and just watch. Lately at BNZ, we've had heaps of developers go and sit in on user interviews, and it's been unimaginably valuable. At every single session, for every single person in the room, there's at least one huge assumption that's just been completely destroyed. So if you have access to user interviews, customer sessions, if you can speak to your designers and UX researchers, go and try and sit in the background. I cannot recommend it enough. If you don't have access to a design team, observe end users. And when I say that, I mean people, everyday people, not your friends who are tech enthusiasts. The best way to understand their mental model is to develop real empathy for everyday users. And of course, as before, we can infer their intent through context, through who they are and where they are. The second way about this is to influence their model. And the thing to remember is that when we make, we teach. And whenever someone interacts with something we make, they learn. The path of least resistance often becomes the default way to do things. So if that's dismissing 10 security warnings in a row, that'll be the way they do things. So here's another question. How are we already influencing our users' mental models? I assume we've got some Mac and Apple users in the room here. I'm sure we've all come across the random iTunes pop-up that asks you for your iTunes password all the time. I don't think they do this anymore, but they used to do this. And while it's technically fine, you enter in your password, you make sure iTunes is okay. It's all good. But the thing that they probably didn't consider at the time was every time that password pops up, it's training us to enter our password in without thinking. Here are some screenshots. The one on the left is from iOS. The one on the right is a phishing attack. Pixel by pixel, they're the same. I don't think we could blame anyone for falling for that. So, what are we teaching? Are we teaching people that they should ignore warnings? Are we teaching them that security is an obstruction? Understand the end user's mental models. So, I have a thing. Is it secure? Well, it's meaningless to ask that unless we first ask, who is it secure for? Under what circumstances, under what context is it secure? What are your users' mental models? Seek to understand their mental model of your application, your product, or even your company, and speak to that model rather than the details, ins and outs of what you understand. I hope everyone's been taking notes. There'll be a pop quiz. Here are some takeaways. Cross-pollination between design and security teams is really rare, and that's a huge missed opportunity. We should be friends. All of our jobs are about outcomes based on specific goals rather than the patterns that we follow day to day. And remember to align the user's goals, the end user's goals, to your security goals. We can do this by finding intent. We can do this by collaborating with design to craft secure paths of least resistance. We can do it by understanding their mental model of what's going on and communicating to that model. We're almost done here, but I'll leave you with one final anecdote. And this is absolutely true. So on one of our floors in our office, there's a little light switch next to the door with a Post-it note pasted over it that just says no. Can you guess what the first thing I did was? Remember, build rivers, not walls. Thank you.